Right. Hi everyone. We are going to have the core sprint, second core sprint for this sprint, which ran from October 12th to October to today. Um, so as an overview, this was a 3-week sprint. As general tradition, we accepted a whole bunch of stories, 167 points. We've completed 54, but 50 of those are in progress.
Ali, can you share your screen?
Say again?
We are not able to see your screen.
That's annoying. Yeah. It unshared. Unshared. How about now? Yay, nay?
Looks good, yeah.
Okay. That was good. All right, so we've accepted 167 story points. 54 of those have been completed. The kind of the silver lining to all this is that we have 50 points that are in progress in various states. Some close to being completed, some of them not started, but we're basically have a lot of points that are built on different issues. So obviously, as usual, we're a little more, our eyes are bigger than our stomach, but we'll get better at it as time goes on. So the first thing that was done in the sprint is a refactoring of the AAA application. It's refactored to use the network config subsystem in ONOS. It uses standard UDP transport for the radius communication. We've implemented it to use MD5, where before it only used the TLS, I believe, and now it uses other way around. It only used TLS. It only used MD5. Now we can also use MD5, and a AAA app. And has been tested with the supplicants, and so we're pretty confident about it. For the OLT, we're getting very close to getting good coverage of all the features we need. There is a few issues with the OLT software itself, where it's kind of unstable, and it's kind of an ongoing work with PMC to make that piece of software more stable in the face of controller disconnections, flows being removed, kind of general operations of an SDN controller, which right now it's kind of shaky. Well, it's very shaky, but the features are getting very close. There's a few bugs here and there, but those are solved relatively easily. So we've tested group operations. The only thing that doesn't work right now is that if you remove an entry from a group, the OLT doesn't actually remove it, and forwarding still gets pushed to that port, which is a bit annoying. But it's better than before. Q&Q support is now, so upstream tagging works. Downstream tagging still needs testing, but we haven't been able to see it in operation. Meter support is operational and returns the right error codes in the face of errors, and rate limiting works. The latest OLT software supports the latest VOLT software supports multiple OLTs, which is something that we need because we're going to have multiple OLTs in a system, honestly, in a single pizza box. But the abstraction to expose a capability is not very convenient, and there are discussions going on about how to change this abstraction. We're negotiating essentially with PMC to get a better abstraction. Also, the ONOS OLT app now also pushes Q&Q tags to the OLT using the Q&Q support, at least in upstream. As far as multicast, this is essentially the support for IPTV. We've implemented a multicast store and designed the multicast application, and the implementation of this application is currently in progress. This work that's going to happen
Halloween.
It's Halloween. And this is work that's going to happen a bit in coordination with DirecTV because their multicast application is similar to what we're going to do in Cord, except they transport this is details, but they transport IGMP and PIM through the core of the network. We don't, but essentially it's the same thing. Any questions up to now?
So you see the multicast store is a new store, or
Yeah.
in the
It's a
core?
very, very simple store that allows you to store any arbitrary. The idea is that you have the store, and then you have people that feed information into the store, usually IGMP applications and PIM applications.
Okay.
Basically, the IGMP are sinks, and this is a traditional view, right? IGMPs are sinks and PIMs are sources, and they basically enter state into the store, and you can switch out the applications that feed that state. So it's separated out. So the store is kind of like a standalone element.
Okay.
And the idea is that all the different multicast applications will use that store going forward. So we tried to make a nice abstraction for all this. We don't know if we have it right. As usual, when we build things, right, we don't know if it's 100% correct. But the hope is, while we're coordinating with DirecTV, is that they can port their application, we can write our application against it, and kind of like get a centralized, not centralized, but like a single implementation of a multicast store rather than every single application bringing its own store to the table. So it's a bit annoying.
Makes sense. Yeah.
Okay. Yeah. So in the VTN, in the core VTN support, we've implemented in ONOS and support for extensions, so OpenFlow extensions, in the context of core to explicitly support Nicira tunnel extensions, but this ONOS support is kind of generic, and it allows us to support specifically the Nicira set tunnel destination and set tunnel source extensions that allow us to kind of control where a tunnel is pointing dynamically. And we also have the ability to spawn and provision virtual networks from OpenStack from a given neutron OpenStack configuration, and VMs that are spawned.
Somebody needs to mute.
Yeah, someone needs to mute, and if you don't do it, I'll do it for you.
Fabio, you.
Sorry, guys.
Oh, no worries. Okay, so yeah, so when we spawn these networks, the VMs that are in them can now communicate. It's not what we want in the actual core VTN application, but it gets us a step closer to implementing our own pipeline and do our own service chaining through the system. So we're closer. We're not exactly there yet. For the fabric, let's Saurav take this one.
So lots of things going on in the fabric side. For ONOS, Charles has been working on supporting regular L2 bridging within a subnet, so basically within a rack for the fabric, and he has put in code that uses some of the support that comes in OFDPA for doing flooding of broadcast traffic and also unknown destination MAC traffic. So, and we found some bugs with that and fixed it in ONOS. The L2 bridging is going to be done in two different ways. There's the one which is the normal learning stuff, and then there's this other sort of SDN-based, you already know what the destination MAC is, so why learn kind of way. So we also figured out a procedure whereby when XOS creates a VM, we need to assign it an IP address. We also assign it the MAC address, and we can put that MAC address in the leaf switches learning table in the L2 table. So we never have to learn the MAC address because since we are the ones who are assigning it. So the L2 stuff will be written in both non-learning and learning manner, and Charles is working on that right now. He also completely moved the segment routing app to the network config subsystem, so we don't use any of the old config anymore. In the meantime, I'm working on moving this the entire app to the OFTPA driver, and the OFTPA driver already exists, but doesn't have many of the things that we're using in the segment routing app. So we started that move. We've moved the filtering objectives, and we'll work on the next and forwarding objectives next. In the meantime, Flavio has been doing a lot of testing, continuing to do testing and finding bugs in Broadcom's OFTPA code. One major bug that we found this week was not in the OFTPA code itself, but it's actually in the hardware, the chip hardware. But luckily, there's still ways to get around that bug in the hardware, but it's not going to take days, it's not going to take months, but it will take a few weeks to fix. And so Broadcom's working on that. In the meantime, both Flavio and also AT&T have found issues with how OFTPA handles VLANs for both untagged and double tagged traffic. So right now, the only thing that works is single tag traffic. So Broadcom has been made aware that we need this. So they're doing that. And then Flavio continues to test learning support, bridging support, and multi-controller support in OFTPA. What we did not touch at all this sprint is we wanted to get Criterion involved in doing automated tests using OFTest, but we never really got around to giving them access to the hardware that we have in our lab. But now with I think the next sprint we will definitely get them that access. Also, the architecture documents need a big refresh that we never really got to because writing code took up a lot of time. So we intend to do that in the next sprint. And now we have all the hardware that we need in-house, but we have to install it, and the cables to connect all that hardware, the switching hardware, that's also been ordered. I think yesterday, so I think we'll get that within the next couple of weeks. So we're starting to build our pod, right? Actually, I don't know about the servers. The servers
are ordered, as far as I know.
The servers, those are the same server we're talking about, right?
Yep.
I haven't checked with Evan overseas. We actually got to check.
The what?
We have an invoice, but we have to prepay them to check first.
Oh.
Amount of money.
So the ordering process has started.
Okay, and the
cables, you said they will take a couple of weeks.
It takes 10 days to.
The special cables. They're QSFP plus, right?
Yeah, these are 40G DACs. So everything here is 40G, and that's why it's not something that we already have in-house. So the idea is that in this next sprint, we will be starting to build the pod. Not just the switches, but the servers, everything, at least we'll hook them up. And so even the pawn equipment is on order, right?
Pawn equipment, no, not yet.
I just asked for a quote.
Yeah.
For 2 months.
Okay. So I think our goal should be at least we should have all the equipment in-house and installed this next sprint, including the pawn equipment and the servers and the switches and the cables.
Sure.
And everything.
So with the fabric is going to be in a kind of state of flux.
Yeah.
So do you have will there be a way at least for we can abstract out the fabric so that we can actually get end-to-end?
Well, at least the L2 stuff should be functional. So you don't need the entire fabric,
no.
But at least if you all stay within a subnet, the L2 stuff should be functional this next sprint. So
Let's clarify on the double tagging. If the outer tag is a 1Q, it will work. And actually, the workaround we're using currently is Nick just retags the 1AD, puts another tag, puts that, we're eating into you. But As long as the outer tag is a 1Q, the traffic will pass.
Well, Nick has been doing that in the ACL table. I'd like to see that work in the VLAN table because
No, so it's in the VLAN table. For both untags and 1AD packets, you need to push a tag to allow the processing by the pipeline. So to do the 1AD, I just add a third tag, a 1Q tag, and when it's getting out to the ACL table, it's going to a group to stop the tag, and we basically we are tunneling the 1AD packets by adding a third tag for processing.
It's ugly,
It's ugly, but it works.
but yeah.
okay, I'm sorry, you broke up a lot when you were speaking, so I didn't quite catch everything. Let me ask you a yes and no question.
Okay.
Yes or no question. Can you add double VLAN tags to the VLAN table? Yes or no?
Can I add VLAN? Can you repeat the question?
On the VLAN table.
Yes.
Okay, that's good to know.
But so what I'd like is an ability.
I'm adding the tag in the VLAN table, if that's the question.
Double tag.
You can take.
No, I haven't been able to double tag the VLAN table. No.
So that's no. Okay. So yeah, I think there are still issues there. That you know.
So, but what I'd like to see when we build the pod, since the fabric, and that applies to all parts of core, they're going to be in different states of development, and while it's worthwhile for us to build the pod, we have to have ways of abstracting out components so that the end-to-end communication can still happen with, say, the OLT missing, right? So for the fabric, we need to have just like a layer 3 switch somewhere where we can just plug our compute nodes into just to have L3 communication enabled, so we can abstract out the fabric and make it work. It shouldn't be a problem. We can just replace it with any switch, right?
Sure.
But I just want to point out that it applies for OLT as well as the fabric, as well as vRouter stuff. All that stuff should be able to be kind of like hidden or abstracted or disabled, so that we can actually test other parts.
Right. So let's design that.
Yes.
Ali, a quick question. So in the ONS, the part with the demo is to use the two ONOS-based controllers. One is for the fabric, and another is for the control plans of the Vivo IoTs. What's the current plan?
Same thing.
Same thing?
Yeah.
Okay. Are you going to merge both in the future?
No.
No?
Not that. Maybe. Okay, but no. Well, it's not in the plan. Right
I
now.
think he's asking. Did you ask if there are separate controllers for
Separate controllers.
So
Yeah.
there's a separate controller. There's one for access and one for fabric.
Yeah.
Right? And so he's asking if those two controllers will be merged into one. They can. Technically, it's feasible. But right now, there's no reason to do that.
Didn't you want to do?
No. I wanted to keep them separate.
I think the technically is tough.
Because one of them can actually be hosted. One of them can actually be a service. One of the core control, one controlling the access side can be spun up as a service, as opposed to the fabric one, which cannot.
So you assume that both controllers potentially will not talk to each other, right?
There
Because
is-
you're separate.
There is a little bit of coordination
Okay, so through the orchestrator.
through the orchestrator or through
Just REST.
just REST APIs.
Okay.
So we have any other questions? Sorry. So we have a couple demos. So the first one is from Andy and Scott, I think. Yeah. How do I just?
You should be able to jump. They can just jump. They can just present it.
Yeah. So it's
Hey, Ali.
Yeah.
Before we do the demo, can we? I think our slides are kind of out of order. Can we go ahead and do a summary of what we've done? I think it's just the next couple of slides.
Okay, let me do that then. Okay, so that's okay. Go ahead.
Yeah. So there's a number of developments for XOS. So we've got a core development environment running on Cloud Lab. So this is about the automated setup and configuration of all of the software components of Cord. So this development environment integrates the OLT and the virtual BNG ONOS apps. They're installed and running. There's the data plane from the ONS demo. So we've got a client talking through the VOLT and the VCPE and the VPNG out to the internet. So this is like 95% working right now. There's still an issue with the VOLT that we're debugging, but all of the pieces are there. They seem like they're configured correctly. It's just not quite working. So, but yeah, the setup is basically there. The whole setup is automated using Tosca configurations with XOS. And I'll give a brief demo of this in a little while. We've also made progress on ONOS as a service. So this involves some changes to the XOS data model and UI and Tosca support to add some new objects. There's ONOS service objects, which are managing VMs and containers, and then ONOS app objects, which are loading ONOS apps into ONOS and configuring them, setting them up. So we've got a synchronizer. We built a controller basically for these services to configure ONOS containers and applications. We had a... Oh, is there a question?
I don't think so.
All right, I thought I heard something. We had a meeting with some AT&T folks the other day to talk about their progress building a VSD containers on bare metal solution. We have also been exploring this space a little bit on our own. I think at this meeting we were able to sync up, and we are going to try to get our hands on what the AT&T folks have built as soon as we can and integrate it into our development environment. So that's the plan. But in the meantime, or previously to that, we had been doing some work ourselves to try to get something basic working here. And so Scott Baker has been doing most of this, but it's basically using Ansible and Neutron.
Data public, the code public, and also the red arrow that is user traffic also needs to go through the public. So ONOS should have to control these public, and some parts of the mobile infrastructure like remote radiohead marked with yellow. There are lots of information should be transferred to the application. So we are meeting partners to make the suitable data planes. And there are many approaches for this data model. It is very important, but we need to make a very efficient data model. So it will take some time, and we work with core team together to make this data model. Okay, that's it for now.
I think now we're at the stage where we're going to go to the demo. So I'll hand it off to Andy first.
Okay.
You can take control and share your screen and do your demo.
Okay. Let's see. All right. Can you see my screen?
Yes.
Okay, good. All right, so this is the Cord. We're going to be looking at the Cord development environment running on Cloud Lab. So let me sign into XOS here. So the Cord configuration is setting up an end-to-end data plane for testing and for software development on Cloud Lab. So the high-level picture, so this is the README for the Cord configuration. The high-level picture is this. We have this data plane that's going from a client through CPQD switch and the VCPE and Open vSwitch, and then out to the internet. And we have a couple of ONOS apps that are controlling the virtual switches along the path. So the point of this setup is just to be able to set up all of these pieces and configure them in an automated manner so people can start playing with everything together. So with XOS, we've got some new views, different ways of getting information about the system. So this is how you can choose different views. We have a new content provider view. This is for the CDN, and also a ceilometer view. Srikanth will be talking about the ceilometer view. I won't look at that right now, but we'll take a look at the new content provider view. So this is now integrated with the Cord setup on Cloud Lab, and it's for configuring the CDN with a source of content. So, for instance, the CDN is currently being used to distribute some on-lab content, and so we could go in and configure CDN prefix and origin servers for that content. So those are the views. So this configuration is setting up this data plane and also the services to orchestrate it. So with the services tab here, so here are the services that are being configured as part of the development environment. So we have the BNG and the VCPE and the VOLT services, and these are the pieces of XOS that are actually orchestrating these different components of Cord. And now we have a couple of new services. We have the ONOS VBNG and ONOS VOLT services, and these are actually hosting and configuring the ONOS apps that are running the VBNG and the VOLT. We have the ceilometer service and also the hypercache CDN. So let me go back to this development environment. So this is available in the XOS GitHub repository. So there's a bunch of configurations, and this is the Cord configuration, and there's a README in there that tells you how to actually run it on Cloud Lab. So for those of you who don't know, Cloud Lab is this NSF Cloud effort based on Emulab. They have a number of large clusters where you can go and you can get bare metal machines to do anything you want, but one of the things they make it really easy to do is bring up an OpenStack cloud on the bare metal and configure some virtual networks, and you can really build a cloud from the ground up the way that you want it to look. So we've been using Cloud Lab quite a lot for development, and I think it's a really nice tool. So if you haven't taken a look at it yet, I encourage you to do it. And there's an XOS project there that you can register for, and then you can get access to this. So there's some, if you look at the GitHub repository, there's some directions on how to run it, so a little bit of explanation about what's there, how to access ONOS and configure it. And if you try it and you run into any problems or something doesn't make sense, please reach out to me and I'll help you out, because I think that we really would like people to use this environment to start playing around with Quord. So I think that's about it for that demo. Are there any questions?
Any questions?
All right.
Thanks.
Okay, in that case, I'll turn it over to Srikanth. I think he's going to talk about the Ceilometer service.
Yes, and yes, and so Ali, can you please give me the access rights or something?
Yeah, you should. You should have them. You can just the little green icon. You can share their screen. Little green icon top left side of your screen.
Yes.
There you go.
Are you able to see my?
Yeah, we see your bird.
Okay, that's good. Okay, let me start from where Mandy has left out. So I will log into the. I will log in. Okay, again some echo is coming. Let me see. Okay, you're able to see my screen and able to hear me fine, right?
Yep.
Okay, so I will log into my Cloud Lab and then I'll set up. So let me start with the services, importing of the Ceilometer service into the XOS part. So as Andy has explained, these are the service grid of the XOS, and one of the service you can see as service Ceilometer. So this is done as part of importing the Ceilometer as a first-class service into the XOS. So here you can view the associated slices for this service. So whenever a service is created, we typically create a slice. A slice is nothing but a list of virtual machines plus a virtual network that connects those virtual machines. So for this service, my site Ceilometer is the slice that is created, and then so for any given service, you can create multiple tenants. So this is the where you can find the existing tenants that are created. So if you see here, there is already one tenant that is created for the user, admin user. So we have created as part of the card devel setup in the Cloud Lab using the Tosca automated scripting. We created by default one Ceilometer tenant. What we have done here is per user only he can create one instance of the Ceilometer tenant. So if I try to create another instance of tenant, it will throw up an error saying that you cannot create more than one instance of the Ceilometer service. So if you look into the tenant that is created as part of this admin user, you can see the different information that is displayed here. The one of them is the Ceilometer proxy URL that I was talking about, that is created for this particular tenant. So if you see here, the Ceilometer URL is running in the instance 1078 at the port 88. And another important thing that to be highlighted here is the tenant list string. What this whole Ceilometer service inside XOS does is it will give permissions to the tenants to view the metrics or statistics about the resources that are only authorized for the tenant. So the particular tenant cannot view the metrics for all the resources in the network or environment. Whatever permissions he has on the resources, he will get the visibility into those particular resources. So here it is showing the OpenStack projects that are authorized to be viewed by this particular tenant. So that is the information about this particular tenant, and it also shows on which instance this particular tenant is hosted. So if you see, this is the instance my site Ceilometer 7, and if you go to the particular slice my site Ceilometer, you can see the instance my site Ceilometer is running on 10.11.10.78. For a quick what's happening under the hood to understand, what I will show you is here. So I'm just logging. I'm just logging into this instance that is hosting this particular tenant. So if you see here, I hope you're able to see the what I'm typing here. So if you see here, there is one Ceilometer tenant by name monitoring channel that is running inside this particular instance. So what happens is whenever a tenant is created, a VM or instance is created on any of the available compute nodes, and inside that a Docker container will be spawned up. We have automated using the Ansible playbooks here. So this is the Docker container that is representing that particular tenant. If you go inside this Docker container, and if you just see what's running here is all a Ceilometer proxy web server, which is listening on port 8000, and we have done a port forwarding from the host 888 to 8000 of this Docker containers port. So this particular Ceilometer web server listens on this port for any queries from the tenant application, and on receiving this any Ceilometer query, it applies configured access controls, and before forwarding it to the backend Ceilometer module. If you see what are the configured access controls, I will just quickly show you. So if you see, the XOS has written a config file or access control file listing out what all OpenStack projects this particular tenant has access to. So whenever a tenant makes a Ceilometer query, the Ceilometer proxy server will ensure that the query is related to one of the resources that were configured to be accessed. So this is how this proxy container will enforce particular configured access controls. So coming back to the Ceilometer service, the Ceilometer URL that I was highlighting here is this is the endpoint where the proxy Ceilometer is listening. So for a quick check, you can do a curl command that access the particular URL, and post which you can use any of the OpenStack Ceilometer queries. You can use the V2, this is the query curl command that fetches all the meters existing for this particular tenant. So it will display a list of meters that are existing. Obviously, this won't be readable. So that is where we have done, we have taken up a story to come up with a simple GUI or dashboard, and we found that OpenStack already has a rudimentary monitoring dashboard inside their Horizon framework. So we leverage that Horizon-based monitoring dashboard and embedded inside the XOS as a iframe view. So if you see here, Ceilometer is embedded inside the XOS view. So when you go to this particular view, you will get whatever you see in the horizons screen. I mean, that's why you will see all these kind of check styles and all are derived from the horizon. So I will log into the Ceilometer monitoring dashboard. It takes a while because it runs a background queries for to compute the average statistics of all the metrics available for this particular tenant. So if you see here, today we have XOS resource usage screen, under which we have two tabs, and the usage report displays you all the metrics that are available for the tenants or the projects that are authorized to be viewed by this tenant, this XOS tenant. So when I'm saying tenant, there are two types of tenants here, XOS tenant and OpenStack tenant. One XOS tenant may have access to multiple OpenStack tenants. So if you see here the list of OpenStack tenants, it has access to all the projects that it was created as part of the XOS card setup. So my site Ceilometer, my site clients, my site ONOS VBNG, these were all the slices that were created by the XOS as part of the card devel configuration. And we have done one more don't read into too much into the details of this dashboard, because we have not spent enough time to understand what type of information is getting displayed here. We just wanted to show how the horizon-based dashboard can be utilized or can be leveraged for XOS to build other stuffs like multiple graphs or whatever we wanted to do as part of the later sprints. So this is just a starting point. One final thing that I wanted to highlight is, if you see here, what we have done is, as part of regular services like Neutron, Nova, also we have enhanced this dashboard to display some metrics related to our card components. So if you come down a little further, you will see some metrics that we have enhanced the VCP containers to notify about VCP related statistics. Currently it is displaying some kind of DNS related metrics where everything is zero because there are no DNS queries happening from that particular VCP containers, but the dashboard is equipped or enhanced to display those meters. So just before concluding, I wanted to show what's happening in this container. VCP, if you go to the VCP slice, where my site VCP is the slice for the VCP service, and 10.11.10.79 is the instance where the VCP containers are running. I just want to show you how this Ceilometer notifications are coming from this container. So if you log into that particular instance where the container, VCP container is hosted, so here you see the VCP container is running in this particular host, and if you run on the available process, so you see there is one cron job that is running inside this root context, which periodically grabs for all running containers or all running VCP containers in this system and extract the DNS metrics and post it to the backend Ceilometer framework, which are getting displayed through this Ceilometer view. Yeah, okay, it's again taking a couple of seconds. Yeah, that's pretty much what I wanted to show in this demo. Any questions?
Okay, thanks, Srikant, for the detailed demo. We have one more demo from Hyun-Sun.
Hey, Ali, I didn't get to edit it last night because I was out all night, but I have a quick demo at the end as well.
Sure. Okay. We'll let you soon go, then you can go after. Everybody wants to demo today. One thing at a time. Yours. You have a. You can share. Can you share your screen? She just did, I think. Okay. So select your screen. Just do entire screen. Okay. And then you can now select that. Now it should show up. There it is. Okay. Go ahead.
Sorry. Is screen share?
Should be. It was for a second. You're presenting to everyone. Sure. Okay. There we go. Okay.
I was working on cultivating an application for a couple of sprints, and I will demonstrate what has been done so far. And first, I will. My test environments are all the VMs, and there's ONOS cluster with the 3 instances, and there's a OpenStack controller and 2 compute node, 1 network node. In network node, there's a DHCP agent works as a DHCP server, and there's another agent called metadata agent. And in the compute node, there is only a compute agent, Nova. Initially, it's a network node and compute node and compute node 1 and compute node 2. There's nothing in it. It shows a OpenV switch status, and there's nothing there. And and the OBS are in passive mode. They are waiting for the OBS DB controller to take a control of them. And if admin pushes the information about there's a compute node and network node there with the network config. Now you can see there's a integration bridge is created, and there's a VXLAN port there, which will be work as a tunnel encapsulation and decapsulation too. And actually, we usually in OpenStack deploy, usually compute node has tunnels for each compute node, so there will be a lot of VXLAN tunnels. But Ali and other people recommend me to just create a one tunnel port with a remote IP flow, so you can manage the destination of the tunnel with the flow. So initial node setup is all done. So what you should do next is create a network through Neutron. I created a new network, and I created a new subnet, and there the DHCP agent created a DHCP port in the network node, so you can check it here in the network node. Yeah, there's a new port is added, and in CoreDVTN application actually installs some rules for the port can talk to the other ports later. And we can now create a VM with the network I just created. Let's see.
Dash image? There's a single dash in front of it.
Yeah, I created one VM, and there should be a new port added. One of the compute node 2 has new port here. So a new VM is provisioned in the compute node 2, and actually you can check it here. Yeah, for the VTM pushes some rules to this VM can talk to the other VMs, and I will create another VM with the same network. And rule is updated, and actually this is a
One quick question. When you're creating the VM, where are you specifying the network to be attached for that VM?
Can you say it again?
When the Nova command is issued, where is the network related information is given to that command so that that VM is hooked up to that particular network?
I forgot to say that. Neutron is set to use ML2 plugin and the mechanism driver of ONOS, which is how it is contributed. So all the network-related events will be delivered to ONOS.
I think he's asking when you create the VM, how does it know what network to connect to?
It's in the API call.
How to connect to?
How does it know what neutron?
You have a network identifier. So can you go back to Nova create?
Yeah, Nova create. The default setting is if it is actually I have to do this like nick net ID to the network I have just created. But if you want to attach all the network to the VM, you don't have to specify network. And I just have only one network I have just created, so I just skip that part.
Oh, okay. Thank you.
Yeah, we can see two instances. These are up, and if you see the log, now you have it launches successfully, and you can log into the VM with a console, and you can actually log into the VM with what's it called? Sorry. It's a default serious image. It's a very light image. Oh, it didn't work. Yeah. Yeah, you can see that it got the IP address is set successfully, and you can ping to the other VM. That's it. My demo is done.
Okay.
Was there a VM running the DHCP server?
I'm sorry?
No, the DHCP server was on the head node.
Yeah, there's another node, network node. There's a DNS mask is running.
Okay. Ali, quick question. Yes. So the over here is you create the single tunnel port, right?
Yes.
So the question is where do you apply the per tenant based QoS? All those policies need.
So that happens at the flow rule level.
Flow rules is tough, right? So that when you apply the flow, so one tenant they could create 1,000 flows, right? So the basically original the tunnel port that we create the tunnel port per V extends. Basically, the policies is applied to the tunnel port. After you apply to the tunnel port, that one policies will apply all those flows flowing on that one. So the new features, I think.
You're missing the point here. So when we're using one tunnel port, it's not it's not a criticism of using multiple tunnel ports. That's one. And secondly, it's also our use case is different than the usual OpenStack or VTN use case. Most of our metering happens at the ingress of the system. Okay, so when customers have their internet connection, they're already metered. They arrive metered in the system. You don't need to meter them anymore.
Well,
and furthermore, we can still do the same thing that you're doing, because ultimately there is one flow rule that adds the tag, the VNI that adds the VNI. So we can still have the same behavior, but we don't have to apply it per tunnel port, but per flow rule. Well, for the flow rule that adds the VNI for that customer. So we can still do the same thing. We opted to go with a single tunnel port because we just think it's more scalable. Because if you have one tunnel port per compute node, well then you have n² tunnels. Well, n² tunnel ports.
N ports per node. And you also touch every node on every
node.
Well,
you have n² essentially. N² tunnel ports. Right? And n² tunnel ports, that grows. I mean, it grows fast, right? I mean, it's math. And so
Fast again, does it grow?
So we opted to go for a single tunnel port, which we think is more tractable as a problem.
Yeah, understand. I have no debating about that. The single port advantages. Right. Actually, the way already in the current already the implement that one. So the question here is once we switch over to the single tunnel port, where to apply these policies? The policies, the QoS, the potential security.
Do it on the host point, right? Why can't you do it on the host? But hold on. You can do it wherever you want. It also depends on. I mean, the thing is, you have to understand that like the way you program your network according to your use case, right? You're not necessarily going to use the core pipeline. Okay, we have a special pipeline for our own service chaining that you don't want to use, right? You don't necessarily want to use yourself, right? You want to do SFC, you do SFC, right? So when you build out your own pipeline, right, you apply the policies where it makes sense for your own use case. We're not going to tell you what you're going to do. You do it yourself. Does that make sense?
Okay.
No.
So for us, we have like a group table at the end of the pipeline,
Yes.
which sets the VNI and the tunnel destination for that network.
Okay.
So if we wanted to do per network QoS, we could do it there.
I saw that. Yes. Yeah.
But
So
it's not that we have to do it for every single flow.
Yes. So as a point, yes. So originally I was thinking that someone told me it's I forgot who was per flow based policies applied, and each time when you change the policies, you need to change it every single entries for the flow table. No. Okay. I was thinking it's a scalability concerns. Okay. So this diagram is clear to me. Yes. Yeah. Next.
Anyway, so
Vincent, you're still sharing, by the way.
Yeah, exactly. So this demo is kind of cool because it shows ONOS and OpenStack interacting. You define a network in OpenStack and you can spawn that network. We're spawning VMs right now. The principle is the same using containers. It doesn't change. I think Don, you wanted to have a demo?
How can I release?
You can't.
Okay. So you're going to make me present instead of me.
Yeah, you have to click on the little green icon.
Yeah, well, it just already said you are presenting to everybody.
Yeah, we can't see your screen though.
Okay.
But you have
How's that?
I have to say that you have to present as well. It's weird. I don't know. That's Google, don't ask me.
So if he chooses to share his screen, that becomes part of the broadcast.
Yeah. Okay. So can you see this? I'm sorry. Can you see my screen now?
No.
Yes.
Yes.
Okay.
Yes.
So Andy kind of alluded to this, but what I've been working on is developing a REST interface that allows you to create Docker containers and then externally push interfaces into the containers. Docker has an API and Kubernetes. Nobody kind of really addresses the networking like we need to. I'll run real quick through it. I'm working on trying to get myself to be able to share the code. I kind of gave a rough outline to Scott and Andy yesterday, but just real briefly, we talked about this. Let's go to the customer. So we built a harness that we use to demo it, but like in this case, we've got a customer view. This is I talked to you about the container that's kind of like the virtual truck roll last time. So I wanted to kind of give a demo of how that works. So we're dropping a container onto the customer's LAN, and then running a bunch of different, like some trace routes and some other stuff. It's kind of crude at the moment, but this is live data. It'll keep refreshing and keep running through the stuff. And then I just wanted to kind of give you a flavor of how the API works. Well, let's start here. There's the API. I don't know if anybody else is
This is wonderful.
Is familiar with Node-RED, but it's Node.js. Where Node.js, you have like modules, and Node-RED allows you to do the wiring kind of externally, so you can view it and whatnot. But it's a functional. AT&T's actually invested in that as well. So that just refreshed. The other thing is, like I said, we got a lot of different, like in this case, this is kind of our model. It's JSON. Is that type too small?
Yeah, it's a little tiny. Very tiny.
So anyway, I don't know how to expand it in. Let's see. No. Well, so you can take my word for it. We have a model where you'd say what service it is, what S tag, what C tag, and what particular interfaces this particular service needs. In this case, we're pulling stats off of it. Can you read that?
Not
So
really.
What's that?
We really try. We might be able to.
Well, yeah. 'Cause I don't know how to make the text bigger in Postman.
I don't know. You do Control-Shift+, it usually makes the browser bigger.
Yeah. All it does is make a lot of noise when I do it. So yeah, we can just run through it. So there's an if config that kind of JSONizes an if config. Where you can pull, I mean, this is a live container, so it's pulling a WAN IP. We have like a list running containers that pulls back all the containers that are running. There's activate, deactivate. Anyway, like I said, we're working really hard at being able to share this with you guys and maybe making. I think once I get permission to share it, then I don't have to get any further permission. We'll just put it on a public GitHub and share it. I kind of gave Andy and Scott everything but the actual code. So, I mean, they can kind of implement a shell service to bang against. I don't know. Any questions about this?
Don, I have one question here.
Okay.
So the information that you are displaying here, is it extracted from the VSD containers?
Depends on which API I hit. This is actually doing like a Docker PS in this case. But yeah, so like if I do the if config, that hits that container. It basically does a Docker exec if config, and then I just kind of JSONize it, so it's it's just Java or JavaScript walkable.
So the stats, I'm particularly interested about the stats query. Since there is some stats we can extract from the containers through the REST APIs.
So yeah, I mean you can see this. I can make this big. So these are kind of match Docker APIs, with the exception of like over here I create interfaces and whatnot. But what was that? Sorry. So again, you have this Arena container. Info is just Docker info. Stats. I actually have an exec API where you can pass in a command and exec anything you actually want. One of the cool things about Node-RED is you can set up like a cron job here. So like every minute, I guess I should say, one of the things I do is when you create a container, activate here, or do some validation. I add it to a MongoDB that this is a service that should be running, and then every minute I start up here and get the running containers. I inspect each container, and if it's not running, I go ahead and restart it and reattach interfaces. So kind of keep alive stuff there. Also have like a log of every time you hit the API, what you hit and what you passed in, so that you can kind of go back and figure out what went wrong. I don't know. Does that answer the question you asked?
Maybe I need to understand more. I will check with you offline if I can leverage some of this for my monitoring service. That's where I'm asking the question. So I will check with you offline.
Okay, that sounds good. And like I said, this is really easy to add new nodes. If you can see here, all these nodes I've created. It's real trivial to create nodes. It's Lord, keep doing this. You want to build services. Building like creating a web endpoint is really this simple. There we go. I have a new endpoint. You can make it a Git, a push, I'll whatever you want post and deploy it. So it's a pretty cool thing that AT&T is doing, and we actually have a hosted service for MTX type stuff. Anyway, that's really all I got to show.
Okay. Thanks, Bob. And I think with that, we are. You guys see my screen? You all see my screen? Say yes.
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 No? Oh, present everyone.
That keeps it locked on you.
Okay. All right, cool. So with that, I think we've come to the end of a very, quite relatively much too long sprint demo. And just as a reminder, we have the planning session on Monday at 1 p.m. Pacific Standard or Daylight by next week?
Standard.
Standard.
After Sunday.
All right, and so thank you, everyone. See you next week.
All right, pick up.
Bye.
Bye, guys.